Okay, welcome to the class today. Thank you so much for joining in to the Great Wall online Zoom classes. Today we don't have any new one. Okay, so we already started our class on travel time graphs, and what we did in the last class is we defined what a distance is, if you remember. So we defined the distance, and let me use this other color. We also defined velocity, we also defined acceleration. We also looked at the units for distance. We measure distance in meters. Velocity, we measure it in meters per second. And acceleration is measured in meters per second squared. So these definitions are very important, because each time we want to solve a question, we'll be looking at the definition, and then the definition will tell us what to do to solve that question. Okay? All right. So let's look at the three types of velocity time graphs, or rather three types of travel graphs, which some people say they are just two. Now I'll tell you the reason why others say they are just two. Okay, so before we look at the three types of travel graphs, look at the formulas. These are mathematical formulas that we use when calculating the questions under travel graphs. So we can calculate velocity, which we refer to speed. That is the average velocity or speed. We can calculate it using this formula: distance traveled over the time taken, which can be written as s is equal to distance over t, where s denotes speed or velocity, d denotes distance, and t the time. Then the acceleration, which is equal to final velocity minus initial velocity over time. Now final velocity, we can replace it with v, and initial velocity we can replace it with u, and time by t. So the formula comes a, which denotes acceleration, is equal to v minus u over t, isn't it? Okay, so those are the main two formulas we use when calculating. But others, this formula, this one here, for acceleration, we can still make v the subject of the formula, and we can use it into calculating for velocity. So the formula is acceleration is equal to v minus u over t, isn't it? Now if we want to make, let's say we want to calculate for the final velocity or initial velocity, we can make v the subject of the formula or u the subject of the formula. So there when we cross multiply, we are having v, okay, minus u is equal to 80, isn't it? Which is acceleration times time. But this formula can also be written as, if we take u on the other side of the equation, we're going to have final velocity is equal to u minus, that's plus 80, which is acceleration times time. So if we need the final velocity, we can use this formula as well. It is just the same formula we've just made v, which is the final velocity, the subject of the formula. And if we need initial velocity, we can still make u the subject of the formula, which will just be u is equal to that will be u is equal to what? U is equal to 80, okay, because when we take v to the other side of the equation, we're going to have negative v, isn't it? Yes. That's why always when you are calculating for acceleration, you'll find that for retardation, which is the opposite of acceleration, it will always be a negative. Okay, now let us look at the three types of travel graphs. So the travel graphs that we have, you can see them here. Let me use this other color. We have the distance time graph, velocity time graph, and acceleration time graph. Now one thing you can notice here is the time. Each graph has time. So as we consider time, we consider the distance. As we consider the distance, we consider it with time. We consider velocity with time, acceleration with time. Okay, so let's start with the first one here, distance time graph. So the distance time graph deals with, we look at the distance that we have covered over the time in which we have covered that distance. Okay, rather over that time in which we have covered that distance. Okay, so let's say someone stays here. Okay, so they are at home with they haven't covered any distance, which is 0, and they haven't spent any time because they haven't covered any distance. When you start moving, you're going to school. As you go to school, you cover a certain distance, which we can direct to be here. Let's say you have covered 5 meters. Okay, that's the distance you have covered, 5 meters. But as you've covered these 5 meters, you've covered these 5 meters over some given seconds, or rather over a given time. Okay, and that time, let's say for you to cover 5 meters, you've just spent 30 seconds. 30 seconds. So this is how distance time graph looks like, and this is how the information that it gives us when it is drawn for us. Okay, now let us look at the velocity time graph. So similarly to the way we've considered the distance time graph, the velocity time graph also we can see it from the same point of view. So we deal with velocity against time. Okay, so what is velocity? Velocity is just the speed or the rate at which an object is changing the position. Okay, so let's say an object is here at 0, and then the object goes somewhere there. So we have the velocity here over some time. So for this object to move its position from one position to another, there's some time that has been wasted, or that has been spent. Okay, and as that time was being spent, the object has changed the position from position 1 to position 2. Okay, so the rate at which the object has changed the position is what we refer to velocity. So because we consider this velocity against the time, then it is called velocity time graph. Okay, now under the same velocity, you see, let's say an object here, when it starts moving, as it reaches somewhere here, okay, the object increases its speed. Let's say from here the object is traveling at 2 meters per second. Okay, 2 meters per second. Now here the object increases its speed to 5 meters, okay, per second. So we can see that there is change in velocity. We can see that we have velocity 1 minus velocity 2. Okay, so we have velocity 1 here, which is 2 meters per second, and then the object increases its speed to 5 meters per second. So if we want to find the difference in velocity, if we want to find the difference in the velocity, we are going to have velocity, the difference in velocity will be v1 v2 minus v1, isn't it? The v2 will be the final velocity after the object has increased its speed. Then the v1 will be the initial velocity. Okay, but as this change in velocity is taking place, there is also the time that is being spent. Okay, so we are going to have the difference in time as well. Have you seen? So that time in which the change in velocity occurs, we can write it as t. Okay, so once we write it as t, because this one on top, v1 v2 minus v1 over the time that it in which the change has occurred is what we term as acceleration. So this formula can just change to, instead of using v, because we have involved time and the change in velocity, so this one will just become our acceleration, because acceleration, remember, is the rate of change of velocity. So there is time involved. So there is this change in velocity or in speed is happening over some time, and that is what we define as acceleration. That's why others say there are just two types of travel graphs, because the same velocity time graph, when there is change in velocity, it can change to acceleration time graph. So when we have that acceleration, now we can draw the acceleration time graph here. We have acceleration dealing with time. So here we'll be given the rate at which the speed of an object has changed, and we'll be given the time that it took for that object to change its speed. So this is the acceleration time graph. Okay, so these three graphs are very important to know, because they help you to know what you want, when, and how to calculate what you've been asked for. And also remember the units in which these two are measured. Okay, thank you so much. Now let's go and look at some examples. Okay, let's look at some examples. Let's look at the first example here. Okay, so the first example, you can look at the question there. You can copy the question. I'll give you time to copy the question. The question is, a cyclist cycled from his home for 20 seconds to reach his working shop center. He entered his shop and spent 30 seconds before he started going back home, which took him 15 seconds. And there was an error here, which took him 30 seconds. So we've been asked to draw the distance time graph to illustrate the information above. So let's have our solutions here. Okay, we can have our solution. Okay, so our solutions will be, we need to draw this distance time graph. So remember, we are dealing with distance one side. Okay, so we have distance against time. Okay, so we have distance there and the time in the x-axis. So time will always be in the x-axis, and distance will be in the y-axis. So here we have distance. Okay, so this distance is being measured in. This distance is being measured in meters. Okay, now here we have the time, which is being measured in what? In seconds. Okay, so we know that as this goes this side, distance will be increasing, and also here time will be increasing. So let's draw the graph. So this person is at home, this person is here at home, and then he travels going to his workplace. Okay, so he goes, and it took him, he covered the distance of 40 meters per second. I mean 40 meters, this is the distance, sorry. Okay, now this person has covered that 40 meter, which is the distance, in 20 seconds. Okay, in 20 seconds. Now what happens after reaching his workplace? He stays there. He hasn't covered another distance. He stays there. So he stays there for 30 seconds. So as the person is not moving, the time doesn't stay constant. So the time is moving. Okay, so are we going to write 30 seconds here, because this is the time that he has spent after reaching at his workplace? No, we are going to add. Okay, we need to have the total time in the x-axis as we go to the right. So this person reached at home in 20 seconds, and then after 20 seconds he added another 30 seconds to operate, to do some operations at the shop. So that gives us 50 seconds. Okay, now what happens after 30 seconds? This person comes back home in 15 seconds. Okay, so there we have. Now are we going to write 15 seconds here? No, we are going to add 15 seconds to 50 seconds. Okay, so that we can get 65. So 65 is the total time that has been taken. Okay, okay, yes, hope you've gotten the point here. So what we've answered here is our first question, which is A. Now we can go on and answer question B. So in question B, we have been asked to say, calculate the speed when going for work. So at what speed did this person travel when going for work? Okay, so the speed, we just say speed is equal to distance. We apply the same formula over the time, which will be the distance that this person has covered is 40, over the time is 20 seconds, which will give us 2 meters. Okay, 2 meters per second. Okay, so this is B1. Okay, so this is B1. We can now solve for B2. So for B2, we also need the speed when this person was coming back from his workplace. Okay, so we apply the same formula. Speed is equal to distance over time, which will be equal to, what is the distance? The distance is still the same. Remember, is still covering the same distance when coming back from his workplace. So we still have 40 meters. Only the time is going to change. This time he has only covered 20. This time he has spent 15 seconds walking back home. So we have 15 seconds. Now if you want, you can use your calculator. 15 into 30, we know that it's 2, and then there will be a remainder 10. Okay, so when you put your 10 there, 15 into 10, it counts. You're going to put a point, and then you add a 0. Then 15 into 100, that will give you 6, again 6, again 6. So the 6 will keep on going. You can round the last 6 or the third 6 and leave your answer in 3 significant figures, and this will be the speed in meters per second. Okay, now the second one, the C question, we can have the C, we can solve our C. So our C, there we have calculate the average speed for the whole journey. Okay, so we're looking at the average speed for the whole journey. We'll still use the same formula. So speed, that is the average speed, is equal to the distance, okay, over the time. So the distance is 40 minutes, is 40 meters. Okay, now what was the total time taken? So we're looking at the speed, the average speed. Let's put A there to mean the average speed in which the whole journey was done. At what speed? Okay, so this time we are going to use the total time. We'll use 65 seconds. Okay, so we have 40 over 65 seconds, which is the total time for the entire journey. Okay, so when you divide there, what are you getting? When you divide 40 divided by 65, you are getting, that should be 0.615, and the number continues going. So we have 0.6. Instead of 1, we are going to round off 5 there and get 0.62 meters per second. So this is the average speed for the whole journey. Okay, hope you've gotten something. So this is just one example, but there's another example here. I want you to try it before we answer it together. Okay, you can take a look at it. You can pause a video, write it somewhere, and then try to solve it. I'll solve it in the next video. Okay.